Hello, my name is Chris Button. Thank you for taking the time to view my video. Dannon is the American subsidiary to the French parent company Danone, and Yo Cream has been a well-established frozen yogurt company in the Portland, Oregon area since 1977. Dannon purchased this company in 2010 for $103 million, and this 2-acre plant currently has over 100 employees making over 100 different flavors. During my time at Dannon, I had 3 primary projects. The first project I worked on was piping and loss measurements. When product such as milk or flavoring is finished transferring from one tank to another, it is still left in these hundreds of feet of piping. In order to recover this product, Dannon uses an air blow, as seen here, to push the residual out and into the destination tank. Before my arrival, these air blows were known to be product loss points. The scope of my project involved measuring critical pipe lengths and determining theoretical volumes and cost savings potential from recovering additional product remaining in the lines. Also, I was tasked with evaluating the effectiveness of the current air blow system by analyzing how much of this theoretical volume is recovered and suggest subsequent improvements. I performed experiments by recording how much is recovered from air blowing different pipes. I then compared the theoretical volume and actual material recovery volume from the air blow sequence. For a final deliverable, I created an interactive table for determining line lengths, volumes, and associated cost savings with any air blow, which encompasses over 200 possible combinations. The user can select a tank area. In this case, PT and FT stand for flavor tank and product tank. Once the origin and destination regions are selected, the individual tank numbers are selected. The pertinent information regarding the product transfer from product tank 20 to flavor tank 7, for example, is then displayed in the output column on the right. This includes the total length of piping, the volume in this length, and the corresponding value of that volume of the product. Upon testing the air blows during a run sequence, the pressure had a sharp drop from 40 psi to 10 psi, which was not due to all the product being extracted from the line, as it wasn't. The root cause was the air pressure being too high, resulting in the air puncturing a hole through the product in the line, preventing it from being effectively pushed. Decreasing the pressure and increasing the time will prevent this occurrence and will achieve an annual savings of over $70,000. My second project was sensor and product flow mapping. Before my arrival, Dannon had no calibration schedule or inventory management for sensors such as flow meters, pressure sensors, or temperature sensors. I created a sensor asset inventory system that identifies the locations, serial numbers, and specifications for all sensors within the plant. This information was previously not available, nor did Dannon have a system for tracking the calibration status of these sensors. My sensor asset inventory system, for the first time, provides Dannon with the number of sensors, location, serial ID number, and calibration schedule for all sensors within the plant. This will result in significant savings by preventing product loss due to a lack of timely sensor calibration. Additionally, this will improve the process and maintenance efficiency at the plant by accounting for all the sensor devices and allowing for accurate and timely calibration of these devices on an ongoing basis. Hence, broken or inoperable sensors, as well as improperly or non-calibrated sensors, are systematically highlighted and corrective action can be taken to avoid product loss. A conservative estimate of savings is in excess of $100,000 annually, as there is a substantial volume of product flowing through the pipes. My third project was turbidity meter testing and analysis. After the pipes are rinsed with water, product is used to push the remaining water out of the pipes. This water is pushed out of the pipes and into a drain. This process is set to a fixed time of 330 seconds. At the 330-second mark, a valve turns on and redirects the product into a tank to prevent it from going to the drain. I determined through time study experimentation that the 330 seconds was too long of a set point. The valve comes on at least a full 30 to 45 seconds after all the water has been purged and pure product is going straight into the drain. This time can vary with different products. A turbidity meter was determined to be the optimal solution for this project. A turbidity meter shoots a beam of light into a liquid and the amount of scattered light is measured to determine the density, as shown here. As soon as the density transitions from water to product, the valve will switch and the good product will not be wasted. Using this method instead of a 330-second set time will also achieve annual savings in excess of $100,000. My 3-month internship at Dannon allowed me an opportunity to apply my engineering background to identify and resolve real-world problems that directly impacted the bottom line. This concludes the presentation on my internship at Dannon. Thank you for taking the time to watch my video.